Welcome to UNI-T training. The UTS3000A series is a signal analyzer that can analyze IQ signals. Now let's look at its IQ analysis mode. Let's use the signal generator to send out a 60 MHz sine wave. Set the signal analyzer working mode to IQ analysis mode. What is the role of the IQ mode? IQ mode is capable of measuring both frequency and time domains. In normal spectrum analysis mode, it just scans the signal over a frequency domain. IQ analysis usually uses the hardware chain of the entire spectrum analyzer. There is no excessive data processing such as a digital demodulation process. So, the IQ data is raw compared to the analysis data displayed on the screen of the spectrum analyzer, especially when analyzing a very complex modulated signal. The IQ data results can be exported. It is very helpful for the signal analysis. We can export the current trace or status as well as the measurement data. This is more often used to export measurement data. Why do we need to export measurement data? Because this measurement data is the rawest IQ data in the field of radio frequency. Both vector signal generation and vector signal analysis require raw IQ data. The exported data can be analyzed with our own mathematical analysis software or other softwares like MATLAB, or you can use this data to generate other data or signals. The upper window is the most basic spectrogram. The blue trace is the average trace. You can turn off the average trace in a measurement setting. The yellow trace is just a normal spectral trace. The average type can be voltage, power, or logarithmic power. Most of the time, we use logarithmic power averaging models. This window displays IQ waveform signal. That is the data we want. This purple trace is the I wave signal. The green trace is the Q wave signal. Because IQ analysis is used to test modulated signals. Let's turn on the modulation mode of the signal source first. Then we can see a modulated signal. The IQ waveform window shows the modulated wave. You can see it now. The modulated waveform is a sine wave. Now let's change the modulated wave to a square wave. You can see the IQ waveform is displayed as a square wave now. If you want to change the sweeping width to a little smaller, use the marker feature to mark it. You can see the details in the marker points. The values for the real and imaginary parts are displayed. Let's change trigger methods to single. Move the marker points to see the IQ corresponding value at each location. IQ analysis separates modulated waveforms into I path and Q path. These two signals can express the frequency, phase, and amplitude of the modulated wave. Let's go to the measurement menu. Choose to show only the IQ waveform window. Just look at the IQ waveform. Adjust the time scale and reference level to make the waveform appear clearly. In this example, we moved from 2 milliseconds to 30 microseconds. Also change the reference value from 0 to 10 dBm. So, what's the difference between IQ waveform and the one just tested before? Earlier, we separated the I and Q paths, but now here we see it as a modulated wave. This is the baseband signal in digital communication. It looks like a square wave. We can export the data by IQ to analyze it. You can also see the I and the Q paths of the modulated wave. Especially in the measurement spectrum, you can see how much the phase difference between I and Q channels is.